Kiel. And I'm Reinier.
And I'm Kiel Reinier, and for today, we will be finding the probability of an electron's location.
So now, we will be providing an example of element W, or tungsten. Firstly, we should prepare its electron configuration. After we prepare our electron configuration, we will now use the 4 categories of quantum number. Number 1, the principal quantum number.
Basing from our electron configuration, our last set is 5b sub 4. Determining the principal quantum number with a sign of small letter n. As easy as this is, from our last set, the principal quantum number is 5. We will be basing only at the last set and what its number.
Second, determining the azimuthal quantum number.
Going back at the last set of our example, the last letter is D. So in our reference, the D or diffused is considered as a number 2. So our azimuthal quantum number, or signed as large letter L, is basically number 2.
The third one is magnetic quantum number.
We will illustrate first the orbitals. So before continuing, I wanted to explain on how to draw an orbitals. Basically, if you have S, you have only one orbitals. And since you have number 2 on the upper of S, you have 2 arrows. But if you have letter P, you have 3 boxes. And if you have 6, you have 6 set of arrows. But if you have D, you have 5 boxes. And since you have 10, you have 10 sets of upward and downward arrows. But if you have F, you have 7 sets of boxes. And since you have 14 on the upper letter of F, you have 14 set of upward and downward arrows. So focusing on our orbitals, we will put a guidelines on the last set of orbitals. Determining the magnetic quantum number with a sign of M sub L. The magnetic quantum number is here. Basing on our last set of orbitals, here in D, we have 5 sets of boxes, but we only have 4 number. So that meaning is we only have 4 sets of arrows. And the last set of arrows is stopped at the +1. So basically, our magnetic quantum number is +1 or only one?
Last one is the spin quantum number.
It only has two answers, positive 1/2 or negative 1/2. To determine the answers, see these examples. So, the incomplete upward arrow is positive 1/2. The sign of spin quantum number is representing big letter M sub S. In that, we have 4 incredible answers. In concluding, the N or the principal quantum number is 5 because the last set of electron configuration is number 5. So the principal quantum number is 5. While the second, the azimuthal quantum number, is basing in our reference if the D or diffused is considered as number 2. While the magnetic quantum number is basing on our orbital. The last set of arrow was stopped in positive 1. So basically, you can use positive 1 as your answer or only 1. In spin quantum number, we have only 2 answers, negative 1/2 or positive 1/2. The negative 1/2 only answered if the orbitals has a complete upside and downward arrow. But in our case, we have incomplete upward arrow. So basically, our answer is positive 1/2.